My name is Sobia, and my teammates Gabriel, Kamisha, and Lydia are all solution architects at Amazon Web Services. According to World Health Organization, there are 300 million colorblind and 285 million visually impaired people in the world. So what do the numbers tell us? When we look at the challenges faced by colorblind and visually impaired people on a daily basis, they arise from the simplest of activities. For instance, colorblind individuals have difficulty differentiating between colors, and this becomes very frustrating whenever they're cooking or preparing food. On the other hand, visually impaired people have to rely on their senses or memory due to impaired sight. In order to understand the exact challenges faced, we observed Kate, a colorblind individual who wants to cook a simple meal for her family. She tried it recently and it was a disaster. The meat was overcooked and the texture felt like rubber. Tonight, she wants to try again the recipe and find a new way to improve cooking the meat. Before looking at Kate's progression, let's examine the reality of colorblind people with some examples.
Okay, so on the left-hand side, we can see that the meat is quite red and the texture is squidgy. But as it cooks and moves along to medium and well done, you can see that it loses this bright color and it becomes tougher in texture. However, on the view of Kate from the right, from what she can see, you can't observe this change in pigment quite so well. And they can't rely on texture alone because meats that need to be cooked all the way through, such as chicken, could still be raw elsewhere. Let's have a look at another example. So in our basket of bread here, you can see that one of them has sprouted a nasty patch of green mold, which would probably get you quite sick. But on the picture that's about to appear on the right-hand side, you can see that it would be difficult for those with red-green color blindness to detect this difference, and it could be confused as something as common as moisture on freshly baked bread. So we narrowed our key primary problems to the cooked state of meat, the ripeness of fruit, and the detection of mold. And people like Kate often encounter safety risks such as eating mold or contracting salmonella from uncooked meats. Now we're going to introduce our solution. We endeavor to solve each of our obstacles by developing a mobile application that can highlight any of the aforementioned issues for the user with the use of their camera in real time.
So, here we have Kate attempting to cook steak. She launches the Chromatic Cooking app and is welcomed by a simple monochrome screen. Here she chooses whether she wants to control the app via voice or manually. She has a variety of foods to choose from, or mold detection, but since she's cooking steak, this is the option she goes with. She positions her camera over the plate and the app confirms to her that the meat is still quite raw. This bounding box will usually encircle wherever redness is detected. She also has the option to use a timer here to help decide cooking time. Here we can see the timer has elapsed and soon it will advise her to flip the meat. This is what is seen from Kate's perspective of the steak as she flips it over. We applied a filter to the video to simulate what vision is like for those who experience red-green colour blindness and what Kate is seeing as she flips the meat over in the pan. Assessing with the app, it's alerting her that it's still partially raw, but Kate wants hers well done. So she flips the meat again and resets the timer, and we'll see what happens next. And now on another assessment, we can see that the steak is indeed fully cooked. Kate wants to take extra precautions, so she cuts the steak in half just to make sure that it's been cooked all the way through. She also wanted to have some bread as a starter, but was unsure if it was still safe. From her perspective, it seems fine. This time, she tries out the voice interface powered by Lex.
I want to check mold on my bread.
Give me a moment, I will check your bread.
The app automatically captures the food, creating a hands-free interface for visually impaired users.
There is mold detected.
And we can see the bread wasn't as safe as assumed.
Okay, so now that we saw a demo of the solution, let's take a look at how we built this on AWS. The two main components of the app is the object detection and classification of potential food issues and the voice assistant for visually impaired users. The object detection and classification was implemented using Amazon Recognition. The Amazon Recognition platform is a managed computer vision platform for image and video analysis. Its label detection feature makes it easy for customers to automatically detect thousands of objects, scenes, actions, or concepts. For the application, we used Amazon Recognition's custom labels feature to build 3 models to detect different objects such as whether meat is cooked, if fruit is fresh, and whether there's mold on food. To use Amazon Recognition, all we had to do was upload our datasets to the platform, use Recognition built-in labeler to label the dataset, and then Recognition built and trained the models from the labeled datasets. After training, these custom models are exposed through APIs for inference. When Kate wanted to check whether his steak was cooked, the base Recognition API was called to determine what type of food was in her image, and then we called our custom detect raw meat API to check whether her meat was cooked. So this was a quick and easy way to tackle the challenge of determining whether food is safe to eat. To make the app accessible to visually impaired users, we had to create a virtual assistant. For this, we used Amazon Lex. Amazon Lex is a service for building conversational interfaces into any application using voice and text, and it's also the same technology that powers our Amazon Alexa. We use Amazon Lex's chatbot type functionality to create a voice interface, which we brought into the mobile app's workflow. Amazon Lex understands natural language, so when Kate asked, "I want to check mold on my bread," Lex would understand the variations of that sentence, like, "Is there mold on my bread?" or "check for mold." Amazon Lex also supports different languages, which makes it accessible to a wider audience. Now let's take a look at the entire application on AWS. We use Swift to build out the front end of the application and AWS Amplify to configure the back end, which integrates with AWS services. The app uses APIs to communicate with the AWS cloud through Amazon API Gateway. When images are captured through the camera, the requests are sent through Amazon API Gateway. An Amazon Lambda function is triggered, which is our serverless compute, and stores the images in our storage service, Amazon S3, to be used later to improve the performance of our custom recognition models. The Lambda function then calls the Amazon Recognition API to analyze the captured images. So by using Amazon Recognition and Amazon Lex, we were able to build a powerful accessibility tool to help visually impaired individuals prepare food in a safe manner.
In conclusion, you can build intelligent accessibility tools by including AWS AI ML services like Amazon Recognition and Amazon Lex. You can build models with small data sets that scale rapidly, and you don't have to manage infrastructure. Amazon Recognition and Amazon Lex are managed services that can scale up or down depending on your business needs. So you don't need to manage and build any machine learning infrastructure. What we mean by managed service is that AWS will take care of the infrastructure while you can focus on achieving your business outcomes. Finally, no machine learning expertise or code required. If you want to detect an object in an image, or you would like to build conversational chatbot interfaces, you don't need to build them from scratch. Instead, we have API-based services such as Amazon Recognition and Amazon Lex, such that any developer can add machine learning to their applications without any machine learning expertise. Thank you so much for listening. We're now open for questions. Please fill out the survey by scanning a QR code. We really appreciate your feedback.
Thank you very much for your interesting talk. it's always useful to have ML systems that we can use without having any proficiency in machine learning or any prior knowledge in AI. So we have a lot of interaction in the audience. We have one question from Wissam, who says that it's refreshing to see how we can combine different off-the-shelf ML services to create a useful service for people in need. Do you have some statistics about the number of users of your system?
I can take that question. So actually, this is currently a prototype. So what we've done is we've used a very small number of users to test out the features, but we haven't put it or published in such a way that we can look at a larger audience and gain feedback of that. But that's something that we should definitely put in the roadmap.
Another question from the audience. How do you evaluate the performance of your models?
That's a managed platform, and what we use there is it's a managed platform, so it automatically trains our models for us, and we measure, and it gives back a few metrics such as precision, recall, and F1 score, and from there we measure our metrics using that, and then we have a metric of, say, around an 85% on our F1 score.
Great. Another question, what is the impact of the lightning effect on for example, for this specific application when you take a picture or when you're moving around with a video, what is the impact of the lights on your prediction?
That we used, so we bought our own custom data set, and there we took into account different lighting conditions, different camera angles to take into account the different different use cases that may occur in real life.